Welcome to the dynamic learning hub of XLR at Andheri East. A prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We have also been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. The hybrid mode is a game changer as you can enjoy the benefits of a live classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Want to get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. XLR. We don't just train, we build careers.
Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
It was a great course and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank XLR for being a part of it.
I was very much interested in learning digital marketing course for a very long period of time, but I don't get a proper platform. So later from our college, I get to know about XLR and I enrolled in XLR course. It was really good experience. Our course has been taken by Mayur sir, and he was very good teacher. He not only focusing on theory part, he is doing how real digital marketing works, and it was in total very good experience. I get so much of knowledge. Here they're not only focusing on study, they are also conducting different exam to test our knowledge, and as we are giving the exam, so to appreciate our work, they give certificates for the toppers, and along with the certificate they give hampers. Thank you, XLR.
Recently, I was searching for digital marketing courses online in Google, and I came across XLR, and I attended a digital marketing course which was for 15 days. My mentor Mayur helped me for attending these classes. So he is a very informative and helpful guy. In the course end, there is a exam which I topped, so I came to the XLR office in Bengaluru. This digital marketing course has helped my career and my skills to develop, and the certificate has helped my company to join. Thank you, XLR.
I came to know about this course from my college. Actually, for learning platform, this is very nice, and I learned from here ChatGPT and AI from online. Because he's teaching for me for AI generative and ChatGPT. We are using this technology in more. And after finishing the courses, I came for collecting the certificate. I seen the classrooms and faculties. Classroom is very nice. After the completion of exam, they will give gift and certificates. Thank you, XLR, for giving these courses. I learned a lot from this. I gained the more knowledge from here. And thank you for XLR for teaching us.
Hello guys, I'm Vikram Mahajan and I'm studying in Swami Vivekananda Institute of Technology College, and I came across a training program which was mobile app development using Flutter, which was given to us by XLR Solutions. I came across this program through my college faculty who told us about this program, that it is a very good course and you should enroll in this course. So I enrolled in this course, and initially I felt
Good evening all. Students, kindly inform your friends to join the session. Only 29 participate, so please inform your friends to join the session as soon as possible. Okay, we will start for the day. Sir, is I audible?
Yes, ma'am. Yeah, thank you.
Yeah, okay, so you can take over the class.
Okay, ma'am. Thank you. Good evening, everyone. So today we will study about supervised learning, and in that I will take linear regression. So yeah, let me share the screen. Yeah, I hope that screen is visible.
Yes, sir, it is visible.
Okay, thank you, ma'am. So we just recap whatever we have covered yesterday. Yeah. So today our topic is linear regression, and we will see that how linear regression comes under the supervised learning. So we will try to understand the basics first, and we will have many things in this session that we will do hands-on practice for the simple linear regression, and if time permits, so we will take multiple linear regression also, and we will do with data set, and we'll try to implement our linear model using scikit-learn Python library. So let's start this session. So as we have learned yesterday that a machine learns, if a machine is learning something, so how it's going to learn? Basically, we need data. And on the basis of data, we need also algorithm. So this algorithm will define that what type of the task, machine learning task or the problem you are going to solve. And that will depend on the data also, that which type of the data you have, whether you have data with the labels, target value or not. So yesterday we have seen that machine learning can be of different types. That one we have seen supervised learning, second unsupervised learning, and third we have also seen reinforcement. So today we'll take about the supervised learning, and we'll see how different algorithms are there, different algorithms, and we will focus on the linear regression. So just look about the data, that what types of the data we need. So in that supervised learning, basically, if our data is data having that is X part, that is our input feature, and Y also. So that is called labels at the target. And on the basis of this target value or the label, it will depend that whether we are going to perform a linear regression or the classification task. Okay. So supervised, generally we are taking the regression and classification. So yesterday we have seen that if our target value are the labels, or the categorical, or the discrete, so this type of if our data y means output labels are categorical value or the discrete value, so we are going to perform classification tasks. So this type of the data, if we have our data and the labels and the targets are discrete or categorical values, so you can perform classification. On the contrary, if you have your labels or the target values as continuous values, continuous real values. So if you have continuous real values, so you are going to perform regression. So let's understand what is regression and how you are going to perform. So in this, we will see different types, different things. So most of the time that see what I have decided to cover here today. Let's see that if time will permit to cover all the things. So what is regression? We will focus on the linear regression and why we are going to perform regression or the what is the scatter plot. Okay, so you can perform using matplotlib or even the scatter plot and different types of the plots you can perform using pandas library. So in pandas library it's also providing the plotting things, and we will see that correlation coefficient how the if see suppose that your input feature, this is your data, the input, and your output are generally we say the target. Okay, target, or if classification is there, so classes are there. But we talk about the regression. So our target will be let's say that we have, if we have only one, we have only one feature, let's say x only, and y is only we represent x with input feature and y as a target variable. So in that what we'll do, that we try to find out the relation between these two, target value and the input. So we will understand that what different types of the correlation can be. Okay, like positive correlation, negative correlation, and if there is no correlation. Okay, so our correlation will vary from the range -1 to 1. If correlation is +1, then we are saying that it's 100% correlated, means this feature is correlated to this feature 100%. And if minus positively correlated, and if -1 is there, so we will see that this is correlated 100% but in negative pattern. Okay, so for the positive correlation, you can see that this type of the linear line you will get. And for the negative correlation, if your x is here and y is here, so your input feature as x axis we are taking, and the output of the target feature, target variable we are taking at y axis. So generally we represent with x, capital X and small y. So if this is the relation, so we can say that its correlation is person coefficient will be minus, and this will be the plus one. Okay, minus and plus. So if no correlation is there, so we can say that it will be 0. Means either you will get some line, something line that either parallel to x-axis or parallel to y-axis. Yeah. So we'll also see, we'll implement simple linear regression using scikit-learn library, and we will plot the scatter plot, and we'll see the how you can find the correlation coefficient, and we'll see the multiple linear regression. What will be the multiple linear regression? So just to understand, if we have only one feature, that yesterday's example we have seen, that if an object is there, a car object or bike object, so numbers of wheels may be one feature. Okay, so if you have a data set that has only one feature in your input, so you are going to perform a simple linear regression. And if you have a data set something like that, it has more than one feature, more than one input feature. So it may be like x1 and x2. Okay, so 2 features, 3 features, multiple features. So we are going to perform multiple linear regression. So let's go. Let's try to understand basically what is regression. Okay, So as we know that we have our data set, and in that we have input features and output variable. So in that your input will be input feature, maybe X, and this will be your output feature, that is your target. So you have to find the relation between Y and X. So let's understand some terminologies that generally what we say the input features. Input features are called generally that or the independent input features are called independent variable. If we go with the variables, in that we study in programming and mathematics, that what are the variables? Independent variable. And the target or the output target variable will be, we will say it as dependent. Why we call this type of the things? Why it is called dependent variable and this will be called independent? Because whatever the input given, we are trying to find out on the basis of the input, we are trying to find out a relation that can predict a y value. Okay, so y value can be predicted something, you can find, we will find some equation. Okay, so if we have only one independent variable, so our scatter plot, let's say our scatter plot we have plotted, and we get a linear equation. We can fit our line, the data points, our points, and we can find a line. So that line, this line can be represented if we have only one variable input and one output and the target. So we can fit something like you will get a line, let's say this line, and the point where it intersects. So we have gone through the basic mathematics, and the slope of this line will be your m. Okay, so if you get these things, a slope and the intercept, so you can fit something like that. So mx plus c. So this will be your line, and in the regression analysis or the linear regression analysis that we will look, that it will be for the simple linear regression. So we will implement all these things. Okay, but just to understand that how it works. Okay. So the main purpose of the regression analysis is to find a relation between output of the target and the input features. So if you get if you are able to get a relation between these two variables or these two features, so you can predict the target value on the basis of the input feature. Okay, so you are doing a regression analysis, you are trying to find a relation, and that relation will be a linear line when we are saying that linear regression. And correlation, we will see that what is the correlation, how much one variable is correlated with another variable. So we'll try to find out Pearson correlation coefficient. So on the basis of that, we will see that whether it is positively correlated or negatively correlated. We will understand all these things. So on the basis of the past result, machine will try to learn a relation may be like this, a linear relation, and on the basis of that relation it can predict the future values for the future input values. Okay, so these are the things that we have to go through, and it will okay, so that generally what we say that this variable, the output, the target value can be predicted on the basis of the input feature. So the input feature also sometimes called the predictor variables, and the dependent variable that we know that these values will be predicted. So let's go to the next and try to understand in detail a little more, and then yeah. So simple linear regression, we'll understand about simple linear regression, and we'll implement this model or the. So simple linear regression, if you go through these things, so it will have only one feature that we generally call the input feature, and one output, that is target. So if you are taking any these type of things, so if you take an example of the the used car cost and the mileage, okay. So if miles driven is given, so you can find a relation between that, okay, this used car, uh, the distance that has covered, that how many miles it has uh, driven, okay. So on the basis of this, you can find the car or the car cost. So what can we do? We have one input, and we have, let's say that it will be something. So here it will be this miles driven. That is our x-axis, and this is our y-axis. So and this will be you, let's say, just cost. Okay. So it's obvious that if the car has like it has driven many miles, so it will, the cost of the that car will be less. Okay. So used car is there. So that should be some negatively correlated, this type. And if you are trying to find out the height and weight, so what will be? If you say that if you are taking weight, let's say that height here, height and weight. So if height is high, generally height is more. So generally we can say that on the basis of the observations, that we can say that weight will be more. So it will be positively related. Positively related. So on the basis of the data observations, we will try to find out a relation that will be like this. Okay, we will understand what are these things, beta naught, beta 1, and this will basically error. So we'll try to find out a statistical relationship, and yeah, that will, statistical relationship will also have some part of the error. So we have seen that in the linear regression, that we can perform linear regression if our target variable is continuous value, has continuous value, means this y value is a continuous, so we can perform. So basically in linear regression, we have one input feature, and we have only one target feature or target value. So on the basis of these, we will try to find out relation. So let's take an example of, this is very good example, that if you say that here, the experience and experience and salary. So this is y and this is x, that input feature is experience, and output or the target variable is our y and the salary. So on the basis of this will be our experience, and this will be our salary. So you can see here, if experience is increasing, so our the salary in general way, salary is also increasing. Somewhere as stagnant is there. But if our experience is increasing, so salary is also increasing. So we can say there is a correlation, means positive correlation, and on the basis of that we can find a line. Let's say that a line fit that will fit best these data points. So all these we are going to say that this is a data point. When we say that data point, okay, this is another data point, another data point, these are generally we say. We also say it as a sample. Okay, this is another sample, another sample. Okay, samples, first sample, second sample, third sample. So so whatever 2 and 50, 2 and 50, this will be your this data point. First data point 2 and 50, x-axis 2 and y-axis, this is 50. So we can plot this way, scatter plot, and we can see on the basis of this scatter plot what type of the relation it can be. Okay. So our main goal is to find a line, this line, and when it will intercept on the x-axis, that we will say that it's beta naught. This will be the value of this will be beta naught, and the slope of this line will be our beta 1. So we can represent this, if it is x and y, so we can represent y as beta naught, that this will be that we have seen if you are going y is equal to mx plus c. So on the value of c is basically beta naught we are representing, and beta 1 as this m, the slope, and x is our the feature, input feature. So here it will be salary. So you can write here input is experience and y is the salary. So you can write salary as beta naught plus beta 1, and you can have the experience. Okay, so whatever the experience is. So now we have to find out this line. So when we are going to use our model, scikit-learn, so we will train our model. Okay, so basically how machine is learning, that is our task. The main task is to find how the machine is going to learn. Okay, so our main goal is to find this beta naught and beta 1. You see beta naught and beta 1. That is the coefficients, or you can say the parameters. Okay, so generally what we say, beta naught generates as intercept. Intercept because this will intersect the y-axis, or that y-axis is generally what is called the dependent variable or the target value. Intercept. So when we train our model, we will get an intercept. Okay, and we will get another that will be coefficient. So always intercept will be 1, and if we have multiple features like 2 features, 3 input features, so we will get beta 2, beta 3, different coefficients we will get. Okay, but in our simple linear regression we have only 2 parameters. Okay, so these 2 are called parameters. Okay, so when we talk about when we'll see that in the programming, so we'll see that our model, so we will train our model, and we will get model will give you these parameter values. Okay, so training our algorithm or training model is basically we are going to find out these parameters, but always it will not be the good or the optimal parameters. So we have to find out the optimal parameter. So how we can get the optimal parameter, we have to see. So let's say we have decided that this line is our the best fit line, but we don't know whether it is good or not. So we decided one line, let's say line 1, and we are going to find out whatever the value here, you will get value here and here also. So let me remove this. Okay, so you will find here values, here some values. This is actual value, this is basically actual value, and this is predicted. The model, this line you can predict. Okay, on the basis of this line you can predict this value. And this is what, why, if you are taking these things, beta naught plus beta 1 x, on the basis of these, you provided this experience, you provided the value and these coefficient value, and then you can get this, the predicted value on the basis of that. So generally we are trying to find that, we say the predicted value is, you say that what will be the predicted value. So to differentiate with the actual value, we are saying that y hat or y cap. Okay, so this will be your predicted value on the basis of these parameters. Okay, and on the basis of the line coefficients, and this will be your actual value. So on the basis of actual value and the predicted value, you will get the error. You have to find out error for this point. So you'll get actual value minus predicted value, and predicted value minus actual value you have to take. So you have to find out the error for all the points. So for all the points you will get error, and this will be another error, this will be another error. Let's say that this will be error 1, and this again error 2, 3, 4, 5. So this type of the error you will have. So what you have to do, the actual, this will be your predicted. So actually this is the value, that is your actual value, and actual value you can get whatever you have predicted and plus the error. Okay, so now you have to minimize the error. That will you get y minus y hat, and you have to find all the errors and you have to sum. Okay, all the errors and you have to sum, and you have to think that whether this is minimum or not. So how you can find? You have to calculate all the error, and you have to check that what is the sum of the error. So you'll find for this particular line, line 1, you may have another line. Let's say this will be the line 2. It's not exactly that this would be straight line. Okay, so maybe you have this line 2. So for line 2 also you have to find the errors, sum of the error. Okay, so predicted value, you just subtract predicted value and the actual value, and you will get, and you have to add for all these things, for all the points, and then you will get. So you have to check one by one all these things, and for which the sum of the error means the error you will get, that is minimum, that will give you the minimum, that line you are going to choose. Okay, so that lines beta naught and beta, these parameters beta naught and beta 1, you are going to take that lines parameters that gives the minimum error. But how we are going to, we are not going to do these things manually. We will use the model, and our model will do when we'll train the model. Okay, while training the model, these things are done. Okay, it will calculate the errors, it will sum the errors, and it will try to find out to minimize the error. Okay, so it will try to minimize the, so model will try, algorithm will try to minimize the error. You can do manually, you can write your own program to minimize the error. So while training, it will minimize the error and it will find the new line on the basis of the that error, and it will update the value of beta naught and beta. Okay, so what we say, this the error is some of the error that we are saying that loss function, we can use loss function or the cost function. Okay, so that we can use to find out the this thing, and the main target of the training will be to minimize this loss function or the cost function. And when the loss or cost function is minimized, so that lines beta naught and beta 1 will be our optimal parameter, and we will use those parameters to find new values. Okay, so let's move ahead and take something else. Okay, so this was the line that you can say that this is the line that is best fit. Okay, the best fit. So if this line is best fitting line, so you will get whatever the intercept will be. Let's say this will be beta naught or C basically. So beta naught will be our intercept. So when model is trained, so the model will provide this intercept, okay, and the slope, and you can get the slope something like that. You take any point, okay, and just try to find this value and this value, and just divide this y and x values. So you'll get your beta naught, beta 1, that will be your generally we say the coefficient or the or whatever we can say slope, we are going to say slope. So we'll see that how the machine after training the algorithm, you are going to find these two, and when you will get these two, you can find your experience and salary on the basis of salary. On the basis salary will be your beta naught, whatever the intercept is, and then after multiplying this coefficient, that is your slope with your experience. So when we will get these two, so basically training the model is to find out the optimal parameter values of these beta naught and beta 1. So while training, when you train on your data set, after training, when training completes, these two values are fine. Like you will get these two values, optimal values of these. Okay, so let's take a business case, the real time case study, and we will implement this also. So we will see that how it will work, our linear regression or the simple linear regression will work. So up to now we have studied regression and basically linear. Okay, regression. So let's regression. So basically regression will try to find out a statistical relation. When we say that statistical relation, then means there is some error included also in the relation. Okay, and for that we are going to find out the statistical relation between. We have studied that this will be one will be your input, and input is your basically independent variable, and the output or target will be your dependent. So between these two, you have to find out a relation, statistical relation, and on the basis of that relation, this relation, you are going to predict. You can use the relation to predict for new values. So this statistical relation, if it is a linear relation, if it's a linear, so it will find out a linear relation, and that linear relation will be modeled or represented using your that we have already seen, y equal beta naught plus beta 1 x, and this will be basically a line, a straight line. If only x is there, okay, then it will be a straight line. Only one feature, two features are there, then you will get a plane or this type of the multi-dimensional relation you can get. Okay, but now what we have given here, we have given newspaper, so this will not give that we have seen yesterday that some features are the bad features, input features, some are good input features. So we'll see that which feature is basically contributing to the relation. So this daily and Sunday. So this newspaper, if you are going to take the daily 391.9 circulation is there, and Sunday this is the circulation. So for all 34 newspapers, we have given the daily circulation and Sunday circulation. Okay, daily circulation and Sunday circulation for 34 newspapers. Now we have to find out relation between Sunday circulation and the daily circulation. Okay, so what you can do, so if you go like this, you can plot a scatter plot, and you can see that whether which type of the relation between these two are. So let's say that it's daily circulation. So daily, we are saying that on the basis of the daily circulation, we are trying to find out the Sunday circulation. So here daily circulation will be there, and here Sunday circulation on the y-axis. So you can get this type of the relation because you see that if the daily circulation is increasing, so Sunday circulation is also increasing. See here, this is 5, then 5, then 7, then 11. So if daily circulation is increasing, so Sunday circulation is also increasing. We will also see the scatter plot and all the things when we will do programming. So you'll get this type of a relation. Okay, so let's say this, you get beta naught and your slope is beta 1. So you can find Sunday circulation with this thing, beta naught plus beta 1 with daily circulation. So main thing is to find out the values of these parameters. This intercept, and this is the coefficient. So these things you have to find, and while training you can get, okay, these values. So you can find here, we'll also see this one, that okay, we have also seen these things. So scatter plot, Sunday circulation, and the daily circulation we have seen. So there is a positive relation between these two, and we can find a straight line that will best fit to this data point, these data points. Okay, so how it is learning? So I already discussed that we have to find out a line, and we have to find the error between the predicted. So this will be your predicted, and these are the actual. The points on the line, these are the basically predicted using this line. So let's say that this line is what, y equal mx not beta 1 plus this circulation, that x is there. Okay, let's say this is x and this is your y. So on the basis of this, that will be your predicted value. This will be a line, and on the basis of this line, you are going to find out the predicted value and the actual value. So these are the actual values, and this point will be your predicted values. So you have to sum, and that you have to find the minimum error. So you have this. This is the same way that we have to find out another line. So okay, so on the basis of different lines, you can find out what are the error. So okay, let's say suppose that you have find the sum of the errors. Okay, here, so predicted value and this, and you will find the all the errors, predicted value minus actual value, or actual value minus predicted value, you can find. So different ways to find. So you can use, you can find the line, and you, whatever the line that gives the minimum, so the minimum error that you are going to choose. Okay, so let's say this line gives the minimum error. So on the basis of this line, you are going to find that this will be the okay. So we have seen all these things, that Sunday you can Sunday circulation you can find out using these things, and this will be your beta naught. This will be beta naught beta 1 daily plus the error. So this error will be basically that we have seen for all these. You can see here that this will be a particular that error for this particular point, for this particular circulation. This will be the error. This is the error. So that thing you have to. This will be on the basis of this. You will find this one. So your main target, when you get this one and this one, so you can find this actual value on the basis of this beta naught and beta 1 and using error. Okay. So that we have already seen that this whole thing will be your predicted value, and predicted value plus this error will give you that the actual value. So error you will get that actual value minus the predicted value, and we are going to sum, and we are going to find out the minimum. We are going to minimize this error. So there are different ways to minimize. Okay. So we are not going into detail of those things, but we'll see that uh, how to implement and how to train the model and to find out the minimum error line. This is the formula to calculate manually. Okay, so beta naught cap and beta 1 cap will be your estimated parameter values. So estimated parameter values basically are on the basis of the on the basis of your data set that you have given. So this is basically very good coefficient of the determination, and that we will see that how we are going to calculate this when you get your model, like you get your model beta naught plus beta 1 x. This will be your model basically. It will be called your model, or the line that is best fit line, and this will be your model. Okay, this will be your model, and on the basis of beta naught and beta 1, that is the parameters, the model parameter, these are called basically model parameter. So whether this model parameter and whether the model that you have that you found the model after the training, so whether it is good or not, so on the basis of one metric that we have, r square metric that we have. So if this metric is this matrix value is near to 1, so we are going to say that our model is a good one, our model is best. And on where the value of this r square is near to 0, so we are going to say that our model is very bad. And if it's like zero point 0.5 or something, so we can say moderate. So on the basis of this, we are going to check that whether our model is good or not. So we're not going to going in detail, it will take too much time. So let's move to So, okay, so we have to do the programming and we are going to implement on the basis of these data. Okay, that these newspaper data. So for that thing, I already have. So let's say let's share the complete one that give you entire screen. Okay. So for that thing, we need our data set. So I have uploaded here the data set on my GitHub. Okay. So you can go and download. So, so you can find here. So this repository, and the supervised, day 2 supervised. So basically just go to this here and you can go into the so I'm sharing here the link of the repository. So please try to download the dataset and the notebook also. So both things I have uploaded here for the day 2 supervised learning, that is regression. So you can see here that this newspaper notebook you download, and you download the newspaper data CSV file. So just take 2 minutes or 3 minutes, okay? And meanwhile, you try to download these two files, that is newspaper data.csv, that is our data set, and this newspaper, this notebook file, okay, ipynb file, that is newspaper. Both are newspaper data, newspaper.ipynb file. So you can download. You can just go like this and just here you can go and you can download the file. And for that also, newspaper notebook, you can download that notebook. Okay, so you'll get all the things that we have to perform. So anyone confirm that you are able to download? Anyone confirm that you are able to download these data and notebook file? We will start implementing when you have downloaded your these newspaper data. And so this is very important that whatever we have learned theoretically, we have to implement also. Okay. So basically I have loaded here, but I am going to close and I will start from the starting, and I will show that how to start from the beginning. Okay. So you download these two things. Here I have given the link. I'm again sending like in the chat. I'm again pasting here in the chat. So open this repository and you will find these files. Okay. So we'll implement newspaper, and for that newspaper data we need newspaper data.csv. So you have to download these. Please anyone confirm that you are able to download these two files. Yes, sir. Now, okay. So downloaded now. There are two ways, different ways to work. If you are using Jupyter Notebook, so okay, directly you open Jupyter Notebook. Either you can also work on Colab also. Okay, you can open Colab. So I think you have been using Collaboratory, Colab, Google Colab. So you can open Colab also, and whatever you have downloaded, you can upload the notebook. You can use upload the notebook, and you can browse wherever you have uploaded. Okay. So let's say I have done somewhere this is, and the second day that we have to do these things, newspaper. It's okay. Multiple linear regression, I have to cover, but it's maybe if time will permit, I will cover. So newspaper data. So newspaper.ipynb, this file you can upload, and when the upload will be completed, so you can start work here. And same way, that thing, if you are working here, so you have to upload your data set here also. Okay, so you can upload your data set somewhere like on sample data or something. So you can upload your data, maybe that you're uploading data, that is our newspaper data, this one. So you can upload here. So when this will be uploaded, this is uploaded, newspaper data.csv. So just right click and you will get the path and just put here the path of this thing. So just you have to change this only, that the path of the where our data set is here, because we are uploading to the Google Colab, and the Google Colab you can't access the data from your local file. Okay, so you have to upload here. So you uploaded here and just you give the path and you can start. Okay, so I will try to work on the Jupyter notebook, and anyone if is working, so same thing, everything is same. Just you go and now just you have to change this path, and after this you will be able to do all the things. Okay. So let's go to the Jupyter notebook. Just open the Jupyter notebook. I already had opened, but now I closed, and just to show you all that how to start from the beginning. Okay. So yesterday I have shown that how to install Jupyter notebook, how to install different Python libraries. Okay. So just we have installed, and you can open Jupyter. You can open your command prompt or any other terminal. PowerShell, using PowerShell you can work. Okay. So just write Jupyter notebook. This will be the command, and it will just enter, and it will open the home page for the Jupyter notebook. Okay. So whatever where you have opened, so I have opened here. So you can check where it is. So it's user and this. So in this directly it is open. So okay, whatever the files you have in that repository, those things will be open. Okay, so go to that wherever we have. So in this folder, I have the things. So you can, I have downloaded, let's say that you have downloaded here that IPYNB file. So you just and open. So day two, we have a newspaper. This data, this file, I have said that open this file and the newspaper data.csv. These two files we need. Okay. So you put these two files in the same directory where this news underscore paper.ipynb file you have. So just click on this and open and you will get your file. Okay. So if someone is late, so I'm again saying that you go and download first. Okay. You go and download these two files and simultaneously do the programming, do these things, run the cells, and you will get to understand how it works. Okay, just this is the repository. So you go and you will reach here in that repository. I have here newspaper.ipynb and the newspaper data .csv. These two files you download and you start working that. Okay. So just give me just 1 minute and you also take for just 1-2 minutes for refreshment and yeah, so we'll start just after 2 minutes. So go let's start the main part that we need. The main part. So first thing is that let's say that how our data set is. Okay. So we have here in our the day two that our data is like this. So we have a CSV file, and in that CSV file, you can see the Sunday, the newspaper name is there, and the daily circulation and the Sunday circulation. Okay. So on the basis of the this daily circulation, we are going to find out the relation whether the Sunday circulation will increase or decrease and how Sunday circulation is related to daily circulation. So let's go to the our data. So just import this. Okay. So for that thing, we are we are importing pandas and yesterday that we have installed. So you can, if anyone haven't installed, attendance sheet will be provided accordingly when time will, I think 8:30, at the time of 8:30 or something. The attendance sheet will be provided by Sushmita ma'am. Okay. So yes, no issue. You can use Colab that I have shown that how to work in the Colab. Okay. So you can use Colab or you can use Jupyter Notebook. So whatever, better to use Colab also. Okay, that's good because you are not going to install all the time. Okay. So locally you are not going to install any library, and these well-known, all the well-known libraries mostly already installed. Okay, you can directly import, and if some libraries are not installed here on the Collab, so you can you can install using. So you can use Collab or you can use Jupyter Notebook. That's fine, no issue. You can use any. So let's go to our Jupyter notebook. Okay, so here, see here. So just import that and run this one. So import pandas as PD. So PD, now onward we will use PD for the pandas. Okay. So pandas library gives you a function that is read underscore CSV to read CSV files. Okay, so just give the path. If you have in the same directory this path, so you just write the name of this one. If you have in different directory, so you have to give the complete path of that directory. Okay, so you import that one and just run this one, and you can find that if you want to find that only first five, so just you can say whatever data frame or data you have taken, that will be. So head will give you first five. Okay. So here you can see that data is something like that. Newspaper name will be there, first column, and the second column is your daily circulation, and the third is all the Sunday circulation. Okay. So we are bothered only with these daily circulation and Sunday circulation. We are not going to take into account these newspaper columns. Okay. Because these are categorical, are the just names of the newspapers. These are not going to influence the relation between daily and Sunday circulation. So we'll work on the numeric data only. Okay. So you data frame, this data frame, pandas data frame has different types of the function, different types of the features. So you can use, okay. So when we talk about the pre-processing and the feature engineering, so we'll discuss a lot of things about the pandas data frame. But here, just to understand the basic things that how our data set looks. So just you can find out the information about the data sets. So it will give you these things that newspaper, this column is basically having 34 values, 34. So you can find that you can write basically here uh, only data frame. Okay. So df, you'll get all the things. Okay. Df.head we have written, so you get the first five, and dot tail you can find the last five. Okay, so from all these things you can see all 34. So starting from 0 to 33, so all 34 these things. So these are the, so in when we are talking about these things, so these one, this will be one sample, this will be one sample. Okay, so these are the one rows are called samples. Okay, all samples, one samples, or the data point, we can also say data points are the samples. So information you can get what type, what is the data type, and what is the, so basically generally when the string is there, strings are the text is there, text values are there in any field, any column. So we are saying that is that column will be object type of the in data frame when we talk about panda pandas. Okay, and other data type is that we have numeric data type with points, so that will be float. That is in that we see in our Python programming that these things are. Okay, so as we discussed that we have to find out the relationship between these two. Okay, daily circulation and Sunday circulation. So this will be your y and x. So we have to find out the correlation, and I already discussed that we will have correlation something like that minus 1 to plus 1, starting from minus 1 to plus 1, and also in between you have 0. Okay. So that this type of the range you will get from minus 1 to plus 1. So the correlation value is if near to 1 plus 1, then you will get the correlation is high. So you can predict means highly correlated means generally we say that this variable is highly correlated. So you can predict value of the dependent variable on the basis of the independent very accurately. If it is like 1 or the correlation is 1 or 0.99 or 98, something like that. So we will see that how to find out the correlation coefficient. So that you can find out correlation coefficient using, so we have to find the correlation between only these two data, daily and Sunday. So we have to take from the data frame. There are two different ways that you can find out these things. So you can say that I am taking these two features or these two columns of the data frame, so daily and Sunday, and we are leaving newspaper name. Okay, so we are taking only these two, and we are assigning into data new variable. You can either you can directly assign to data frame, and you can see now here our data will be something like it will have only two columns, that is daily and Sunday. So we are concerned about these two, daily and Sunday, and we will look into the correlation. Okay, so correlation, it says the correlation. So correlation, if we have, this will basically a correlation matrix. It will give you a correlation matrix. So you are going to say that same variable, same like x with x. Okay, x with x will be correlated with 1. Okay, and y with y will be correlated. Means correlation between same variable will be 1. For the attendance, I am again saying, okay, so this will be provided by the Susmita ma'am, the host of the meeting. Okay, so she will provide when time will be. Okay, I think at 8:30 and something like that. The attendance will be provided, and don't bother about the attendance. Okay, just learn, and if you have any doubt, so please ask. So same variable, if same feature daily with daily, so this means same feature will 100% correlate with same. Okay, so that's why it will be 1. And on the basis of the data that we have given here, the correlation is basically between daily and Sunday, that is 0.958. So it's very good correlation. So on the basis of this correlation, we can say that okay, we can find out a linear relation or the relation between these two. Okay, and the relation will be our positive relation, positive correlation. So this is other way that you can directly take the data frame without refining like this, and you can say here only that numeric values. Okay, so maybe numeric features you have, numeric features are the object type, the string you have, text you have. Okay, so you can provide here numeric only, that will give you same thing. Okay, so on the basis of this you can find out the correlation. And second, that we need to provide the scatter plot. Okay, so we define that correlation. We found that there is a correlation between these two, and the correlation is positively correlated. Coefficient is 0.958. So that is very good correlation. So we can decide that we can find a linear relation or linear equation that will best fit for this data set. So now the next is to plot a scatter plot. Okay, so just you can plot a scatter plot, and why we need to plot a scatter plot? Because this is scatter plot, with the scatter plot you can find that okay, there is a relationship between these two variables, and you can visually see that how the relationship is. Okay, either positively or negatively, or there is no relation, and these things. R language. Yes, you can use R programming, R also. Okay, but why we are using Python? Python. For that, Python has given a good program, the libraries, machine learning libraries. Okay, so like scikit-learn. Okay, we will install and we will see that we are using scikit-learn here, sklearn. Okay, so scikit-learn will give you, just you can check here, just see scikit-learn. So if you go to the scikit-learn main library, main page, so you'll find that for the classification, regression, clustering, for different type dimensional interaction, model selection, pre-processing, or for all steps, for all the things, you are given the models. Okay, you are given the functions, you are given the classes. So for regression, we are studying about regression, and linear models. We have to go linear models and linear. So where linear regression is there, so you can find, just you can find linear regression. Linear models, you can go for the linear models, and you can check all these things. Okay, so linear models, within linear model, you will have linear regression, that will be a class, Python class basically. Okay, so you'll see that this linear model module, this will be a module basically. If you see here, from sklearn import linear model. Okay, so this sklearn is basically what? It's library that scikit-learn you have to import as a sklearn. Okay, so this library will provide this linear model a module. This linear model will be a module, and using this module uh, you can import this one, linear regression class. You can find this linear regression class, and using linear regression class you can define an object. Okay, so that object will be basically our model. This object is model basically. This will be model. This is basically a class, Python class. Just simply we see the Python in Python class and object we have studied. Okay, so this linear regression will be a class, and on using that class we are going to find we are going to create an object. Okay, so this object is basically our model, and that model is going to be trained. So object, this object will contain this fit model. Okay, fit function or the method. This fit method will give you like training. Okay, this will train all this object on the basis of the data. So whatever we have data, so on the basis of that data set, this fit uh, fit this fit method will train the object, this model. This is basically model, and you will get your model trained. Okay, so now you'll get all the things. So after training, you will get these things like coefficient and other things. Okay, so we'll see after training, we'll see how it will work. So that's why we are using scikit-learn, because when you are going for the machine learning, so Python has many libraries, and this scikit-learn basically this has all the algorithms and the models that we are going to learn, and basically all the algorithm related to supervised or unsupervised. Okay, and different types of the supervised algorithms models. So you need not be bothered that you are going to write on your own from the scratch. If you are statistical, more oriented to the statistics, like statistical analysis, statistical modeling, so go for the R programming language. That is the main thing. Okay, so R programming has more statistical methods and statistical functions that are needed for the statistical analysis. And if you are for the programming, for the machine learning, so better to use Python, and Python will give you lots of the functionalities, libraries, and different things. So just plot the scatter plot. So it will give you, you can use matplotlib, and you can plot, and data frame also. This pandas data frame has these things like plot dot scatter. So you use just a give. This is your data frame. Data frame means your basically data set. This is your data set in pandas data frame. Okay, so in pandas data frame, it is something like that we are using in relational database. So just rows and columns will be there. So in a table format. So from that table, we are saying we are taking x, that is on x-axis, that is our daily column, and on the y-axis, that is our Sunday column. Okay, so you can just so I think it will work if okay. So go to the scatter and just plot. Okay, so data frame, whatever the name of this data frame you have given, so you can give data or the data points or the df. So generally we give it df, so it will resemble with data. So df dot plot dot scatter, you will get a scatter plot. So it is required, but not always necessary. But if you plot a scatter plot, then you can guess that there is a relation between which type of the relation between these two data points. So now the main thing is that our model building or the fitting our model. Okay, so when I'm talking about fitting the model, we are trying to find out a relation, something like that. Okay, beta naught plus, again I'm saying beta 1 x. Okay, and you are going to fit this line, and when you are fitting using that we have seen with the scikit-learn model, so you are going to find your beta naught and beta 1 values. So we'll see that what will be these will be the you can find intercept, model dot intercept. So your model, you will get your model dot intercept, and using model dot coefficients. So this you will get beta naught and beta 1. Not always required, but just to check that what are the parameters of the what are the parameters of the model. Okay, so in machine learning training, when you are going for the machine learning, you are going to train the model. So what basically we are doing, we are trying to find out the optimal values of the parameters. So model, so every model, so let's say that before the model, you have data, you have algorithm, and of course these things, algorithm and data, will be run on a machine. Okay, on some machine. So that machine, you are going to say that okay, machine is going to run. So when these things are there and you are going to train, okay, so on the basis of this algorithm, that this algorithm will say that how, what will be the steps to train the model, train the machine on these data. Okay, so after training the algorithm, this algorithm, you will get model. And what basically model is? Model is basically these the line, and that line is actually what? The parameters. Okay. So when you say that you trained a model, means you find the parameters. Okay. You find the parameters. So actually what we are doing, we are training the model, means we are trying to find out the parameters, the unknown parameters. Okay. So in our simple linear regression, and so we have only two parameters. Okay, because one is the coefficient of the x, and other will be the intercept. Okay, so we will see, we will check all these things in when we train the model. Okay, so again I'm saying, I'm going to here is scale-learn part, and I'm saying again that sklearn is very good library, and it will give you all basic, not basic, but almost all supervised and unsupervised related supervised and supervised machine learning models you can find here. Okay, different types of the linear regression models, different classification models, different clustering models, different types of the models you can get, and you can directly import the model, and directly you can train the model. Okay, so what are the steps that we need to understand? So just we have to import the module, this linear module from the sklearn, and then you have to find the linear regression class, and using this linear regression class you are going to create an object. This object is your model, and then you are going to fit the model. So here we have taken from the sklearn, you have taken linear regression, sklearn linear model. So you can yeah, you can do like this also, that particular they have written here. Uh, so basically you can do not exactly this, but yeah, leave this one. The regression model you have to import. This regression, linear regression is basically what? Linear regression is your class of this module, and this scalar is basically the library. Okay, just run this one, and after that we need that our the input feature and the target. So this will be our input feature, and this will be our y is basically. So we are taking data. We are taking data. This you go here. The Sunday one as y, and that will be the target, and daily as a input feature. Okay. So just you do this, and you can find here that x is basically our x is same way as our data frame, but having only one one feature, that is this daily is our input feature, that is x, and y is basically our target value. So these will be our target, that are actual values. And now we will fit the model and we will try to find out the predicted value, and we'll see the difference between the actual value and the predicted value. Okay, so define the model. So this linear regression is, I'm again saying that this is a class, and this model that you can use any variable here. So this will be your object, and this object is basically our machine learning model, and that model we are going to fit. Okay, so this will be fitted using model.fit, and you have to provide the input feature, that is x, and the target value, that is y. Okay, so just go not exactly 30th April, but this will be something, this will end if you go like it started yesterday 1 2, so it's only from the Monday to Friday. Okay, so Monday to Friday, so it will go up to the 5th of May. Okay, Saturday Sunday we don't have classes, so eight classes will be there. Okay, so 30th, up to 30th we will cover like 1 2 3 4 5 fifth class at 30th, then 3 more classes will be remaining. Okay, so you get the attendance sheet, you fill the attendance sheet. Okay, and try to download these files and work on these. Okay, so for those who have joined late, okay, so I'm just again pasting the repository link, and you go and download the files, that is newspaper.ipynb and the newspaper data.csv. Okay, maybe in poster, okay, no issue. In poster, there may be some changes. Okay, but we have classes only on the weekdays, so we have to cover like 15 days program is this. Okay, so it's basically a machine learning program the second day, and earlier you have I think 7 days. Okay, so it's the ninth day. Today is ninth day of this program, so we have to go up to the 15 days. Okay, so you download these newspaper and newspaper data.csv. Okay, so you work. So yeah, just main important thing here that we are going to find out, we are going to train the model. Okay, so again I am saying the training model is nothing but you are going to find out the coefficients and the parameters, beta naught and beta, whatever the parameters are. Okay, so you are going to find out the parameters, and parameters you can get how? Model.intercept and model.coefficient. Okay, so in simple linear regression, when you have only one variable, only one input feature, so you will get one the coefficient, and this will be your intercept. Okay, if you have multiple linear regression, then you will get different, like y equal beta naught plus beta 1 x1 and beta 2 x2 and something like that. Okay, so as many as the input feature will be, those number of the these coefficients you will get. So let's say it is only 3, a model has only 3 features, so what will be you will get 3 coefficients and 1 intercept. So you will get 4 parameters. So on the basis of these things, the coefficient and the intercept and the coefficient, when we trained our model, when we fit is basically, fit is what? Fit is the method of this model object. Okay, this is an object when we talk about in Python. Okay, it's an object. So this object has this fit method, and this method will train the model, and it will try to find out the values, the optimal values of the model. Okay, the parameter models. Yeah. So just run this one, that you will get model.intercept, and after intercept you have to write underscore. Okay, and coefficient also, after coef you have to write intercept. So this will be 13.8. 13.8 will be what? So we are talking about that what the data set that we have taken. We have taken Sunday and daily. So Sunday you can write here, Sunday circulation you can write directly. The intercept is 13 point, let's say in rounded form, 13.8. Okay, plus the coefficient 1.339. So 1.34 you can write, and the daily circulation. Okay, so on the basis of whatever the value you have, let's say that here you have value, let's say this is the case. So for the daily circulation you have 391. So just you multiply this into 391.95, something like that, plus 13.8, and then you will get Sunday circulation, but what? Predicted. Okay, this will be your predicted. So now you will get the predicted using this model. This is your model. Okay, this is your model, and you get model you get these two coefficients, these two parameters. You get these parameters, and that on the basis of these two parameters you can predict for any value, not from the data set. New data, for new data you can also predict. Okay, so using these things, these parameters, you can predict. So where we are here, just go, and so I'm again saying that with the time, side by side you also run the programs, you also run all these things, and see that if you are getting the exact values or not. So what you will do, this will be your, okay. So this is that model intercept and this model coefficient and daily. So you can find here just for the coefficient, and you run y, you will get y you have here. Y is actual basically. Now you are going to predict using the x. So whatever the input feature you have, so you can predict for those, and just you will check that whether the predicted value and what is the difference between the predicted. So you can predict for this x. X is basically what's daily circulation. So on the basis of daily circulation, you are just predicting using the model. Model is what? Model is your linear equation. That equation that we have said, that Sunday equals, you can find the Sunday equals this intercept and plus the coefficient into daily. Okay, this is the thing. And the intercept and the coefficient you find new. These are the parameters, and daily you are giving daily values, daily circulations that you are providing here. Okay, so model has the coefficients, those parameters. So we have in the model parameters, and we are providing the value, the data, that is input feature, and we are predicting the values. So you go and you can find here. Okay, so side by side you can check here that what is the values of y. So let's say the actual y, what is the actual y? So you can see here. Actually, the y is for basically just put data frame. Okay, then you will get the answer. So you go here, you will find this daily. This is x. So for this x, the Sunday value, the Sunday circulation is 488. But our model, on the basis of those parameters, predicted that this would be like 538. So whatever the difference between these values are. So you say here, this is your, basically, this is y actual, and this is y predicted. Okay. So the difference between these two, some difference will be these difference will be there. So those difference are there. Okay. So the statistical relation. So statistical relation, we are again saying the we are finding statistical relation. So in the statistical relation, there will be a term of the error. Okay, you cannot find the actual relation that will 100% say that this is the case. Okay, but in that you can find like this. So you can check. So let's move and see that. Okay. So yes. So what is the thing that we are trying to plot? We are trying to plot the actual data points and the straight line that we have, that we find. Okay, the straight line that we that is our model basically. Okay, so in term when we are dealing with the linear regression, we are saying that linear regression. So what is model? Model is basically linear equation. And in this term that we have taken, this linear equation is basically what? Sunday equal whatever the intercept we got, 13 point something, 13 point that, and plus what was that? Let me write exact. 13.8 and 1.3. Okay. So it was, and 1.33, and that was the daily circulation. So on the basis of this daily circulation value, you can find the Sunday circulation value, but that will be the predicted. Okay, so this will be predicted, but you have some actual value. Okay, so you can find here. So for this data point, this will be your predicted value, and this is basically your actual value. This is your actual, this is predicted. This is your actual, this will be the predicted. This will actual. So how you can find, how you can say, let's say if you want to find the point at this point, the predicted value at this point. So you have to just draw a straight line, just a straight line vertical. So whatever the point will be here, you will get this value. Okay, mathematically. So this value will be your predicted value for this data point, this x value for daily circulation. Let's say this will be 950 or 9 something. Okay, so this will be whatever the values. So using this line is basically what? This is the straight line linear equation in one variable that we all have studied in our metric, the 10th class. Okay, this is that simple. So what you will get? You get your model. Model is basically your linear equation or the straight line when we are talking about one in one variable. Okay, one input variable or the dependent variable. So we have plotted a straight line that is this is the our model. This line is the model that is best fit, and these are the scatter plot of the actual. In the blue, these are the actual data points, and okay. So what you will do? So we find our model with the parameters. We find the parameters and other things. Now, just to find out that what is uh, how well our model is performing. So we have to find out the accuracy basically. What is the accuracy? So the best metric for linear regression or the regression is the R square method. Okay, R square metric. So you can directly find model dot score, and just you have to find give the input feature, and that is why. Okay. So on the basis of the parameters, it will find the predicted value and it will calculate the errors, and then uh, it will find out the accuracy. So it will say 9.918. So it says that our model is 91.8% accurate. So accuracy will be 91.8. So different other metrics are there that we can use to find the errors. Okay, this will be to find the error. So the error should be less if the error is less for a particular line. So that is more, you can say that is better fitting the line. Okay. So you can find different types of the error. Mean absolute error is there, and the mean square error is there, and the root mean square. So you can find different types of it. And from the sklearn dot matrix, you can find R2 score also. Okay. So this R2 score from the matrix and this model dot score, both will give you same thing. Okay. So now just we have to find out the how you are going to predict for the you. Now what you have model. Okay, you trained model, you get trained model. So now you can predict, you can use to predict on new data. Okay, so just define the new data. So you need the data as a data frame. So first you create a pandas series. Okay, just create a pandas series, and with the two new data. Okay, so these are like 200 and 300. That will be the x values, and we are going to find out the predicted value. Okay, so basically predicted value, or we can say the y predicted. Okay. So the predicted values of y. So these are new data. These are not in data set. So basically you can use these things. And just model dot predict and give the new data. Here new data, whatever the data that you are going to predict, that will be, here you can see that new data. Yeah, okay. Data for the prediction is this. So this will be a data frame. Okay. So that's why we have created data frame from the series, and that is the daily column. This is daily. So you have to specify the column name that exactly that we have in our data set. So this will be your Sunday. So whatever it will give the Sunday. So this is the value, corresponding value to 1.7, and it will be 415.7. So this will be the corresponding predicted value for these daily circulations. Okay. So just we can run, just run these, Okay, just let me clear the screen so it will be easy to understand. Yeah. So just run this and this and then model dot predict. So model is what? Model is in when you go in Python. So model is basically an object. Okay. So dot predict is basically predict is your again your method. So it will predict some value. Okay. So these are the predicted value. So again, if you go, I have given here this data. Okay, so this is the same data that it will take two columns. It has two features. Basically, this waste is input feature and 80 is your target variable. Okay, so you can use same thing. Whatever we have done here, everything you can do. Okay, whatever we have done here in newspaper, everything do same way that whatever we have done for these things. And let's check that I have not done these things. Okay, so just you read this and you start from beginning that whatever we have done from starting. So just find these thing correlation you can find scatter plot you can plot, then you can create model and just go and fit the model and you will get the these coefficients. And after that you will try to predict the values and you find all these things. So this is basically an exercise for you so that you can understand properly. Okay, so whatever I have done there, you use this data set. You try to download this. You just go and download this data set and use that data set and you find all the things like your model and then predict on these things. So actually what we did and actually what we tried. Okay. So when you are working on the machine learning on a machine learning project, so one thing is to find your model. Okay. That model is nothing but collection of the parameters. Okay. So these parameter values, they are some numeric values, and on the basis of numeric values, you can predict for the new data points, for the new values. So using these parameters, so if you are building the things, so you have to save these model, okay, model parameters. So you save model parameters. So just you can save, okay, but we are not saving now. When we will work on the complete project, so we will save the model and we will use those model parameter values to predict for the new values, for the new data points. So again, I'm saying here that okay, go for this repository. Okay, I have shared already shared, and you download these just these. Okay, a newspaper we have done, and you download newspaper data and this one wc_80.csv. Okay, so this will give you a data set that is more similar to the newspaper, but it will have only two columns. So let me know if you have any doubt. We are going to conclude our session. So download this data, uh, waist circumference and adipose tissue data. Okay, so you will get this data and do whatever we have done for the this first program. Okay, all these things. So Meanwhile, I recommend that try to do it. Try to run the program that whatever we have here in our digital notebook or you are using if Colab. Okay, so try to run simultaneously that whatever we are doing here. And try to understand. So basically, we are going to conclude here. Same thing we have uploaded. I have uploaded on the GitHub, so you can download there. Okay. So from the GitHub you can download. Tomorrow also I will share link. Okay. So in that GitHub repository you will find. No issue. You're most welcome. So Susmita ma'am, that I think we are going to conclude the session here. So okay, good night all participants, and let's meet tomorrow. Not tomorrow, but on Monday. Okay, because Saturday, Sunday we won't have the classes. So on Monday, 28th, we will meet. So Smita ma'am, if you are hearing, so okay, so we are going to conclude and end the session.
Okay, sir. Thank you so much. So we will wind up for the day. So students, tomorrow and day after tomorrow, Saturday and Sunday, we don't have a session. We'll meeting again on Monday.
Yes, yeah.
Yeah,
Okay,
thank
ma'am.
you.
So yeah, welcome. Yeah. So we are concluding.
Yeah, sure.
Okay, thank you, ma'am.
Yeah, thank you all. Thank you for joining. We'll meet again by Monday. Good night, everyone.